Hey guys, Dr. Boucher here. Hope everyone is staying safe and continuing to learn and enjoy class despite our sudden change to a virtual format. For today's lab, we're going to be focusing on the idea of self-joint mobilization. To understand that idea, we're going to have a quick discussion first about arthrokinematics, the subtle sliding gliding motions that occur at joints. So, first we'll establish the three movements that can occur. We have roll, okay? You can envision a tire rolling on the road where a new point on the tire continues to meet a new point on the road. Just a millisecond later, another new point on the tire meets another new point on the road. Okay? Easy to envision a roll as a tire traveling down the road. We also have glide. Okay, you might look at this and think that the tire is sliding along the road here, but in arthrokinematic terminology, we use the term glide. So imagine your car doesn't have anti-lock brakes, you slam on the brakes, the pavement is wet, and you slide, or we're going to call it a glide forward, so that the same part of the tire is gliding along here, continuing to meet new parts of the road. Our last, spin. For spin, imagine a basketball on a finger. Okay, the same tip of the finger continues to stay in contact with the same point on the basketball, but there is this rotational motion. Spin is something that we can see occurring at ball and socket joints, like the glenohumeral joint in the human body. Next, we'll talk about the pairing of these motions. With spin, we see that at ball and socket joints, and we could see that in isolation. With roll and glide, we typically see a predictable pairing of those movements. Now, as I say that, understand that that is not always completely predictable. What we're going to talk about with the shapes, the concave and convex shapes, is just based off the shape of the bony surface. There are other factors involved, the ligaments in joint capsule, the muscles that are active around that joint. There are other reasons that will influence the way that these subtle sliding, gliding motions occur, and the research is not conclusive on always predicting these patterns. However, we can discuss a general trend, something called the convex-concave rule, and in the top image there, we're going to discuss what happens when a convex surface moves on a concave surface. So the drawing there is a half pipe. If you've ever been to a skate park, you'll recognize that. What you may not have seen at the skate park before is this little guy here. Probably seen one, but not at a skate park necessarily. That's a roly-poly. Okay? Roly-poly is a small insect that when scared, it balls up. So I like to use that for the analogy because the roly-poly can change its shape and be either convex, balled up, or unfurl itself and be concave, which we'll see in the next example. So roly-poly here, it's a young roly-poly, a little on the extreme side, decides to go to the skate park and tries to make his way up the half pipe. So he rolls up the half pipe, but with that hard exoskeleton, he tends to glide back down in the opposite direction. So the roll and glide, when a convex moves on a concave, the roll and glide are in opposite directions. Okay, in the bottom image here, let's say that our friendly roly-poly gets tired of trying to make it up the half pipe, so he leaves the skate park and he goes across to just a general park across the way, decides to go for a stroll along a grass hill. But roly-polies have lots of little legs, and having lots of little legs means more room for error. It's easy to trip over your own legs. And so as he's going for his stroll, which we will call a roll, in this direction, he trips over his own, would say 2 feet, but many feet, and slides or glides in the same direction So you can see here the bottom surface of the roly-poly now is concave. He's walking along a hill that is convex, and the roll and glide are occurring in the same direction. So now let's take a look at some examples in the human body, and then in the next two videos we'll go through those examples in real life. For now, we'll take a look at them on a model. And the first one we'll look at is the ankle or talocrural joint. So let's imagine that you're starting a squat. You're in closed chain, foot's on the ground. You initiate the descent into the squat, and your tibia leans forward like that. The undersurface of the tibia in that example is concave. The top surface of the talus is convex. So we look back to our examples here, we think, concave on convex. And that looks like the roly-poly on the hill. So the roly-poly on the hill, the roll and glide would be in the same direction, so that as the tibia rolls forward, it glides forward as well. So the relative motion is forward for the tibia, the relative motion is backwards for the talus. Okay. Let's say we were in open chain. So the foot's off the ground and we do some ankle dorsiflexion. Now the talus is the moving bone. The talus in this example is convex, and it's moving on a concave tibia. All we have to do is rotate our image a little bit to see that that's like a very large roly-poly moving in a very small half pipe. Okay. The convex moving on the concave is like that top example, so the roll and glide would be in opposite directions. So now, put back to the same position here. As we move in open chain ankle dorsiflexion, the talus would tend to roll this direction, forward, and glide this direction, or posteriorly. So it's the same relative motion. The tibia moving forward or the talus moving backwards, either of those, it's the same relative motion that is paired with ankle dorsiflexion. That'll be important for the mobilizations that we'll look at in the next video. Let's run through another example. Okay. For the hip, if we started with a closed chain movement, stand up and I hinge at my hip, what we're seeing here is the pelvis moving over the femoral head like that. Okay. So it's a concave acetabulum moving on a convex femoral head. The roll and glide then, it's like the roly-poly rolling and gliding forward on the hill. The roll and glide are in the same direction. It's the relative motion of the pelvis is forward on the femur, or we could say the relative motion of the femur is backwards on the pelvis. If we did that in open chain, lift my hip up into flexion here. The femur is now rolling forward, and the prediction for the glide would be that it would glide in the opposite direction, it would glide posteriorly, because this is just like an upside down version of that convex roly-poly moving on the concave half pipe. So the roll is forward, the glide is backwards or posterior. So in the videos that we'll look at next, when we apply mobilizations to this, we're going to expect that for hip flexion, we will try to facilitate a posterior glide of the femur.